Hello, today we'll be going over 1.4, modeling with linear equations, and we're going to do the Let's Practice Problem 1. A deep sea diving bell is being lowered at a constant rate. So remember when we're talking about modeling with a line, if it's going to be a line, the rate has to be constant. You can't go fast, slow, fast, slow. You've got to have that constant rate of change. That slope, that rise over the run is very consistent. That's how you get your line. All right, so that's important. A deep sea diving bell is being lowered at a constant rate. After 8 minutes, the bell is at a depth of 600 feet. After 40 minutes, the bell is at a depth of 1,500 feet. What is the average rate of lowering per minute? Last time we discussed the slope as being the rise over the run, change in y over x, a rate of change, and the importance to see that rate between two units. So let's look at our units this time. We're going the rate of lowering per minute. So we want to add the idea that when we're talking about slope and you're looking at word problems, some good words that represent slope are per, each, every. Okay, so when you're reading and you see, oh, dollars per hour, miles per hour, something each day, every year. So per, each, and every can indicate that we have a rate of change. And in our problem here, we want the lowering rate per minute. And you notice that it's being lowered to a depth in feet. So you can go boom, da 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 da. We're talking about feet per minute. I automatically know that feet represents the y value and minutes represent the x value. The x is time. It just keeps ticking independently, the independent variable. Y is the dependent variable. Hey, how far was it lowered? It depends on how many minutes. So the feet that it's been lowered depends the dependent variable. All right, now that we can see that, let's figure out what's going on. What is the average rate? What does the question ask? They want the average weight, which we know is the slope. And we know the slope is change in y over change in x. Our slope formula, subtracting those y values over subtracting the x values. So what do they give us here? They give us two ordered pairs. So what are those ordered pairs? After 8 minutes, which we know is the x value, okay, so just reminding ourselves, the slope here is the feet per minute. We know that the y value is feet and the x value is minutes. Then we can form our ordered pairs. So after 8 minutes, it's a depth of 600 feet. Okay, and the next one is after 40 minutes. So sometimes students get confused on which one goes in the numerator, which one goes in the denominator. Should I do 608 or 8,600? How does this work? This is the key right here. If you can find your two units, feet per minute, feet will be y, minute will be x. After 40 minutes, the x value, then you've lowered 1,500 feet. Once you can gather that information, you're set. Now you just plug it into the slope formula, labeling whichever point you want. So I could just say x1, y1, x2, y2, plug it in the formula, and you're set. So I'll take the 1,500, subtract the 600. A lot of students forget to subtract, so just remember you're finding that difference. And that makes a lot of sense when you look at the graph, right? Over 40 minus 8. And then, if you need your calculator or not. So 1,500 minus 600 is 900. And then 40 minus 8, 32. And then when you take 900 divided by 32, you get 28.125. So what is the average rate of lowering? Then when you state your answer, make sure you use your units. So 28.125. And remember, this is feet per minute. That's the rate at which it lowers. A rate will have 2 units, feet per minute. Thanks. Have a great day.